Hello, my name is Matt Lydon. Welcome to the Solidworks 101 workshop. For this workshop, I'm going to get right into it. I'm going to assume that you have zero Solidworks experience, but you have somehow managed to download it onto your computer or whatever device you're on. So first things first, let's bring up Solidworks. The number one thing that I really want everyone to remember when we're talking about CAD is this idea of patterns. You're going to be looking for symmetry, you're going to be looking for base shapes, and you're going to be looking for ways to make geometry that are not immediately apparent. And what I mean by that will become more clear as time goes on. So when SolidWorks loads up, you will get to this screen. We're going to start by making a part. Click on part, and your first thing that's going to pop up is this units and dimensions standard. If you're just starting out in CAD, you likely don't need to mess with the dimension standards too much. These are just the international standards like ANSI, ISO, that dictate things like tolerancing or inspection standards. To change your units, click on this dropdown. I'm going to go with inch, pound, second, but that is where you can change that before making your part. I'll hit OK. It'll open a part template for me and come up with this nice blank screen, hopefully. Alrighty, so now that we've got our initial screen, there are so many buttons. Don't worry about what each of them do as of yet. There's one process that you're going to follow throughout all of CAD, and this is where our base shape, simple shape idea comes in. First thing you do is you're going to make a two-dimensional sketch, and then you are going to create a feature from that two-dimensional sketch that brings it into 3D. For example, if you draw a square on a plane, if this plane will highlight, there we go. If you draw a square there and you extrude it up into this direction, you can then get a rectangular prism or cube. So let's go ahead and practice that. I'm going to go over to the Sketch tab, click on my plane that I'd like to sketch on, which is my top plane, and then click the Sketch button. As you can see, it rotated the screen so that I am now looking directly at the top plane. I now have all of these tools up in the left-hand corner. Each of these will create a different one or two-dimensional shape or line. So just by dragging, clicking and dragging, you can create different shapes. I'm going to do that again a little bit slower. I'm going to wait over here, click on the origin. You can see that it snaps that point on. So I go over, see that little orange dot, click once to place one endpoint, click again to place the second. It has already created another endpoint for me, so to create another line, I'll just click one more time. Now I have two. Repeat that process for the next two lines. And you can see that it's automatically giving me these nice snap guides. So this guide, the one that is highlighting blue, tells me that my line is perpendicular to the line I just made. Getting a little bit of lag. This second guide is telling me that I'm directly above or vertically above the origin, which is where I centered my shape. Okay, so now we have a shape, but you can see if I grab this endpoint, if I click on this endpoint and drag, this is not a well-defined shape. I can click it, I can drag it, I can change anything about it. So we need to add some dimensions. So I'm going to go up to the top left-hand corner and click the Smart Dimension button. From there, I'll click on the line that I'd like to dimension, click again to place it, and add a dimension. Let's say 2 inches. I'll hit Enter, and now this line is 2 inches long. I'll do the same, click, drag, click again to place, type 2, hit Enter. Now we have a square. To start making this into a really three-dimensional part, let's click Exit Sketch in our top left corner, click over to our Features tab, and click Extruded Boss Base. What this will do is it will drag our part into our sketch into 3D, normal to the direction of the plane. So let's say I wanted to drag this out an inch. Let's say you wanted to go the other way. The extrude command allows you to do that pretty easily. I'm going to go ahead and make a cube and say that it is going to be 2 inches in height. There are a few other end conditions, which is what this drop-down menu is here. So if I click this menu, you can see blind, up to vertex, up to surface, offset from surface, up to body, and midplane. For the purpose of this workshop, let's just worry about blind and midplane. A blind end condition simply means that it's going to go in whatever direction. You can switch what direction it goes in by clicking this little box with the arrows in it over here. But in general, it doesn't really care. It will go 2 inches in whatever direction these arrows tell it to. A midplane says, okay, you wanted to make it 2 inches tall. I'm going to put 1 inch, or I'm going to extrude 1 inch up and 1 inch down. For this, I'm going to select blind. Hit the green check mark, and now you can see we have a cube. Cubes aren't terribly interesting though, so let's put a nice circle in it. That'll get us towards our more complex geometries, and we'll be able to show how you can generate more complex geometries with multiple operations and then change it later. So for now, I'm going to go up to select this face, go up to the top left and hit the sketch button. I'm going to go down to my little triad here and click the Y-axis to align my view with the view of the cube. I'm now going to click the circle command, which just allows me to click once for the center point with a little bit of lag, and click again to set the radius. In this case, I'd like to put the circle in the direct center of our cube. So I'll dimension the center point to 1 inch and 1 inch by selecting the center point of the circle and the edge that I would like to dimension from. Now let's dimension the circle itself. In this case, I'm going to be a little bit boring. I'm going to make it another inch. Just not too much variance in my dimensioning here. And now you can see we've got that same idea of a two-dimensional sketch on some plane. So now I'm going to hit Exit Sketch. I'm going to rotate my view by clicking the center mouse button so that I can see the part in more 3D. Again, that's your center mouse button. It's a little random, but it's a very useful shortcut to know. To make this a cylindrical hole in our cube, I'm going to click Extruded Cut. The Extruded Cut command is exactly like the boss base in reverse. It will remove material. Some CAD programs will do this in the same button. There's just a little, like a toggle switch or something, where you'd say, okay, I'd like this one to be solid, I'd like this one to cut. But in the case of Solidworks, you're always going to have extruded base or extruded boss and extruded cut. In with the lag. Okay, so we again have our end conditions here, but for an extruded cut, there are slightly different end conditions. You can see we have through all both, up to next, up to vertex, up to surface, and from there it's the same as the extruded boss. Through all is saying I want to cut as far as any part of this body extends. So if I click that, it will automatically set my hole depth to 2 inches, which was what we decided was the length of each of these sides of the circle. If you say through all both, it will extend in both directions normal to the plane that you are sketching on. Up to next will follow to the next feature. So if I switch the direction, you can see that my preview went away because there's nothing above that feature. But if I click again, it comes back because it knows that this next surface is over here. All in all, each end condition has its own quirks and its own uses. If one of them isn't working for you, try using a different one and see how that goes. I'm going to hit the check mark to OK it. So now, at this point, if you're following along, I know I'm going a little fast, but we have a cube with this circular cutout in it. But what if you didn't want to do something entirely 3D? What if you needed to round these edges off? At that point, you can start looking at your modifying features. Goodness. The computer's lagging just a little bit here. Just bear with me. That's not so good. Let me check on the Wi-Fi. Oh, here we go. So, as I was saying, what if you wanted to have a non-two-dimensional feature? Say you needed to round the corner off or something like that. Or rather, let's round off the corner of this circular profile here. In CAD, there are always going to be multiple ways to do something. In this case, we can either use a fillet, which is this feature here, or a revolution, and I'll go over both. But let's go over a fillet right now. So fillets are found up in this feature toolbar up around the middle. So we'll click on each edge that we want to round off. I'm going to do both this side and the other. So now we've told it I want to apply a round here. I want you to round this off for me. But now we have to tell it how much it needs to round it. I'm just picking random numbers right now, but I think that 1/4 inch sounds fine. At this point, it can be useful if you can show a preview, which you can see as a button right here in this Items to Fillet drop-down menu. You can click Full Preview and it will show you exactly what your tangencies will look like. Oh, you know what? I may not have mentioned that the fillet will create a curve with a circular arc tangent to both faces that intersect at an edge. That's, I think, the formal definition. But for most people, it's just you're rounding off an edge. So I'm going to click the green check mark for that. Now you can see we've got this nice rounded off edge as opposed to these sharp ones. I'm going to do one more feature on this part. And then we will move on to a different example. So let's say we wanted to cut out a section from the middle. We wanted like a circular section out of this cube. It might be a little difficult to find the plane again, to extrude it down. And depending on what other features you have in a part, you can kind of combine them, so to speak. So for this, I'm going to select the plane, or I'm sorry, I should explain what we're going to do. We're going to create a revolution. We're going to create a 2-dimensional profile and sweep it around an axis to create our final shape. Kind of like if you had a cylinder, or rather, let's think about a washer. If you had a washer and you broke it down into 2 rectangles and you rotated that rectangle in around its center axis, that is what a revolution is. So let's try that. I'm going to start a sketch on my front plane. Yeah, we can do that. Let's do it on the right plane. Getting some lag again. Okay, I'm going to use the middle mouse wheel again to fit the mount or rotate to the right view and click this view orientation cube over here. My apologies at the sporadic use of hotkeys. I'll do my best to explain what I'm doing as I do them. But in general, these are your view keys. So if you, let's say you wanted to not see the edges on your part because you want some fancy view or you're taking a fancy screenshot, you'll go to this multi-color cube, I guess is what it's called. You can do this one where it's just a wireframe without hidden lines. Add hidden lines in. And then there's this one, which is just hidden lines have no special formatting. That's the word. Great. So going back to our view, I'm going to click the view cube again and click on the side that I want to view. Let's create a center line. This is what we're going to be revolving our part around. I'm going to grab a line, line it up with the center point, click once, click twice, and I have a line. Now that we have a line, let's specify that it's for construction. So we'll go over to this left property manager and click the for construction checkbox. Now that we have our checkbox, I'm going to do the same thing that we were just talking about, where we have this rectangular profile. To get the rectangular profile, I'm going to go over to this corner rectangle, click the button, click once to lay one corner, click twice to lay the second. Let's set the rectangle's width to be, I don't know, 1/4 inch. Seems to be one of the numbers of the day. Let's set the depth of the rectangle to be 1/2 inch. Lastly, let's set the position of the rectangle. We want the rectangle to be positioned. I'll click the Smart Dimension button. It's always helpful. We want it to be positioned 1/2 inch from the edge of the, or I'm sorry, yes, from the center of our revolution and 1 inch from the bottom edge. Now remember, this is going to revolve it around this axis, not the center axis of our part. So I'll click the Revolved Cut right here in our Features tab. You can see it automatically selects my profile and my center line. Now that we have this sort of washer type shape, if we click the check mark, you can see, although not very well, this kind of circular profile that we have that extends into our hole. I don't know, maybe you needed to do some wire management or something like that. One very nice thing about Solidworks is that you can change any part at any time or any feature. So if we go over into this left panel called our feature tree, we can go back to our original feature, which was our first extrusion. If we click the drop down, we see this first sketch. And if I click on that sketch, you can kind of see the outline of it, along with our 2 dimensions. And you right click on it and click the Edit Sketch button right here. Now that we are in this sketch, what if we wanted this one edge, just this one, to be 2.5 inches? Upset the balance of the world a little bit. I'll click the check mark. Or I'm sorry, I didn't explain that. I double clicked on the dimension itself, hit 2.5 and enter. Now we can either exit the sketch here, or in all of your sketches, you will have another option of exiting with this smaller right-hand button. I'll click that one this time. You can see it has automatically updated our features. This is kind of the magic of parametric modeling. You can go back and change mistakes or change parameters later that you may not have had full information on, or maybe had to design change on without having to just click the undo button all day. Let's try a different example. I'm going to go up here, click on File, New, and we're going to start another part. This time, it won't ask us what our preference is for units or drawing standard. If you want a different unit or drawing standard, you can go over to this right-hand corner where it says IPS and choose any other unit system. If you need a different drawing standard, you can edit that in the document properties. That's a little beyond what I think we're doing right now. Okay, so in this case, or for this example rather, let's try to make an object that everyone's going to recognize. Let's try doing a pencil. A number 2 pencil. So when you're looking at a pencil, what do you see? Can you break it down into 3 base shapes? Cones, spheres, cylinders, prisms. If you're following along online or in the future sometime, I'll give you just a couple seconds to think about that. Okay. So a pencil is going to be made up of effectively 3 parts: the eraser, the stem, and the sharpened part of the stem where the lead comes out. I'm not going to do a hexagonal pen or pencil because that would involve a feature that we haven't learned yet. However, you can break down, if we think of like those lettered pencils that you got sometimes in elementary school or middle school, the ones that have a circular shaft, a conical tip, and a cylindrical eraser. That's what we're going to model here. So first thing to do, go over to your Sketch tab, click your plane, start on the top plane again, and click Sketch. At this point, let's think about how we're going to make the pencil. In general, the fewer features you have, the easier it is to update your model. So when I look at this pencil in my head, I guess, there's a single line of symmetry, or there's a single axis of symmetry around which everything is circularly symmetric, which means that we can revolve. So if I draw a construction line here, I'll wait for it to snap onto my origin here, just like that. We can revolve one profile around that whole line, or around this line, and get the whole pencil. So let's go ahead and do that. I'll click Insert Line, kind of draw the rough shape of my pencil here. One important feature of a sketch is that it has a closed surface. And Solidworks will tell you if your profile is closed because, or by showing you this nice shaded area in the middle. Right now, because this is a construction line, it is not a closed profile. So I'll go ahead, click the endpoint here, snap that on. Oops. When you click this endpoint, snap it on there, and then click again when it snaps onto the second endpoint. And now you can see it's got this nice shaded region in here. I'm going to click Exit Sketch, go over to my Features tab, Revolved Boss Base. And you can see it's automatically chosen my axis of symmetry, or sorry, my axis of revolution as that construction line we set. And our profile is the only closed profile, so it automatically chose that as well. I'll hit yes, and this is effectively the shape of a pencil. If we want, we can click this drop down, right click, edit sketch. We can change all of these dimensions. Let's say we think that this is too thick, and it might be. We can make that much thinner. Average pencil is probably only 1/4 inch thick, which means that the radius that we are dimensioning right now is 1/8 of an inch, or 0.125 inches. Average pencil is probably, what, 8 inches long? No, 6 inches long. And when you sharpen a pencil, you're probably not going to want less than half an inch. See if that looks good. Yeah. Not a very scientific method of dimensioning our pencil. However, it gets the idea across. I'll hit Exit Sketch and it should automatically update. Just like that. If you wanted to add more detail in, say you wanted to do a hexagonal pencil, we can go on to a plane that is normal to our profile and click Sketch. I'm going to go over in a triad, align myself with the sketch, and grab this polygon tool. By default, it'll give me six sides. I'll snap onto my origin, go over here. To really understand what we need to do with the hexagon, though, we need to understand a little bit about geometric constraints. So these little green windows, they've been popping up this whole time. These are our geometric constraints. This one says that the center of this polygon must be coincident with the origin point. They've drawn a little radius in this polygon, and they've said each side is tangent to that circle. So what we need to do is we need to click on this line and go over to our little left tab thing here. If we click the horizontal button, it has now applied that constraint. That line is only allowed to exist horizontally. If I hit the escape button and drag this, you can see I can't rotate it at all. I can only make it larger and smaller. Oops, automatically put placement for me. The next constraint we need to add, we can do by selecting one of our corners. This circle here, hold Control, select both, and hit the coincident button. Now you can see, oh goodness, I'm lagging here. You can see that we've got this nice inscribed hexagon into our pencil shape. But we want this to be, again, a closed profile because we're going to cut each of these little sections out of our shape. So to make this a closed profile, for each of those a closed profile rather, I'm going to click and drag a circle that is just larger than the radius of our hexagon here. The reason it doesn't matter what the radius is, as long as it's bigger than the hexagon, is because everything, ooh, goodness, the whole pencil itself is inside of that hexagon. You will not need anything, rather anything else. So I'll hit Exit, and then we can go to Extruded Cut. I'm going to go ahead and say through all both. Pretend that our eraser has fallen off somewhere, I guess. And click the green check mark. Now we have a nice hexagonal pencil. Again, if you wanted to go through and make fillets or whatever else on here, you can just go through, click the fillet button, click each of your edges, which you might be able to click through to obtain, but you know, that's okay. Doesn't matter. We'll get there. Let's say your radius is only 5/1000th of an inch. Hit enter, you can see this is such a small radius, but kind of changes the look of our model. Okay, so I want to really quickly review that process that we went through to get to this model of a pencil. So I know that this workshop has been a little bit everywhere, but I hope you're bearing with me here. We thought about what we wanted to make. We know that it's a pencil. We knew that the pencil had certain features, like the tip. The tip is the most important part because that's what we write with. We want the handle or the long, I don't know, I'm going to call it the handle. Those are the critical features of a pencil. That's how it writes. The next part that you're going to think about is what features can I break this down into? Oh, that hexagonal part of the pencil, it kind of looks like a cone or like a cylinder. Okay. The tip of the pencil looks like a cone. I can revolve that around the same axis. Those can be one feature because they're both symmetric, circular or circularly symmetric around the same axis. They could be included in the same revolution. To get our cut extrude or our hexagonal shape on this pencil, we thought to ourselves, okay, we know that the pencil is only going to be so thick, or we know that this hexagon is inside of this cylinder. What if we just took out the little sections that weren't part of the hexagon? And so that's what we did. We went through, we set our sketch up, we drew our hexagon, and we made a radius or a circle with a radius greater than the hexagon. From there, all we had to do was say, okay, I want to extrude this nice region where the hexagon isn't. And that gave us this really nice shape. The number one thing about Solidworks is just patterns. The buttons are confusing, the hotkeys are confusing. But if you can figure out how to break your part down into its basic shapes, spheres, cylinders, cones, rectangular prisms, these are going to be your tools with which to make your parts. Let's see, how am I doing on time? I got a couple minutes here. So why don't we go over one more example and we might be able to go over just one more feature that I usually find pretty helpful. So I'm going to click New. I'm going to hit OK on the part. Go over to my Sketch tab. Click Sketch, click a plane. Okay, for this example, I'm going to make a nut. Like a nut and a bolt type nut. So I'll click our polygon button, wait for that to snap onto our origin, and drag that out. I'm going to apply a horizontal constraint to the top of this hexagon. And I'm not going to add a circular center hole in it, although you are more than able to do that in Solidworks. If you wanted to add that here, you could extrude everything but that section. But in this case, I'm going to show you a different feature. Before we leave the sketch, let's dimension this hexagon itself, because having a 6-inch wide nut might not be as helpful as we like. Let's say we're making a nut for a 1/4 bolt. I'll go ahead and make the nut face 5/16 of an inch. so that the technician doesn't cut his fingers on our nut, I'm going to click the fillet button over here. There's a sketch fillet and there's a 3D fillet. This is the sketch fillet. I'm going to make our radius 5/1000 of an inch. And just click through 1, 2, 1, 2. Each of these are connecting edges. You can also select the actual vertex itself. You know what? I'm going to make this radius just a little bigger at 8/1000 of an inch. Click the check mark, hit the exit button, go over to our features tab, and extrude this shape upwards. Let's say 1/4 inch. Why not? That's a little bit big, so let's go 5/32. Looks about right. So now let's make another sketch on this top face. I'll select the top face, hit the sketch tab, sketch button, align my triad, click the circle tool, and drag a circle outwards. I'll dimension it to 1/4 inch and set it to construction. This is where the twist is. And we'd hit the exit sketch button, features, hole wizard. The hole wizard is an extremely useful feature, I guess feature creation tool. Excuse me. Because it allows you to create standard threads and standard holes for standard parts. So like we said, we're going to do a 1/4-20 bolt. I'm going to go over here, hole type. We want a straight tap. So that just means that we're going to go all the way through without a counterbore or something like that. I'll go over to our hole specification. This is where we choose our thread. So I'm going to go over to 1/4-20. Our end condition is through all. We have standard tolerancing. For position, I'll just switch over to this tab, click our face, and then click the point that we created. Now it looks like in our preview, it's trying to do this nice fillet, or sorry, chamfer on our edge. So let's go over here and click uncheck near side countersink. We're going to click the OK button. And it looks like it's created our 1/4-20 tapped hole in our feature tree. Now let's say I don't want to have a 1/4-20 thread anymore. Maybe I just want this to, for whatever reason, to be a spacer. I don't want there to be threads in it. I can right click, edit feature, just like we can edit sketches. Go through over here. I think this is the clearance hole. Yeah, here we go. And so now this should tell us we have a diameter of 0.25. So now it's just a regular hole, should be. Yeah. So this diameter is 0.25. We can now slide our bolt into that and have another nut clamped down on top, whatever we need it for. Point being, you can edit the feature just like you can edit a sketch. And Hole Wizard is an extremely useful way to get good threads into your part instead of trying to, I don't know, model those in by hand. Anyway, we are just about out of time for our workshop. The 3 things that I really want you to make sure you take away from this workshop are, number 1, think about what you are trying to do. If you're trying to make a pencil, what does it need? It needs a handle, it needs a tip. Number 2, once you know what it has to do, how are those things alike? Or what are the minimum number of features that accomplish your tasks? So in our case, we had to make a conical tip, we had to make a cylindrical or hexagonal handle for it. Number 3, how are those features alike? In our case, the conical tip of our pencil and the cylindrical base of our handle shared an axis. So we revolved both of those features at the same time around our axis. I'm going to add bonus points because we then modified that feature to better fit what we think of as a pencil by creating that hexagonal shape and extruding away everything that we didn't need. So that's just an intro into some of the things that Solidworks can do. I hope that this workshop has given you some confidence to go in and play with it. Because really, that's the best way to learn it. It's just to go in and play. Without further ado, I think that's it for me. Thank you so much. Have a great rest of your day.